Hi, this is Sai Joshita Katari. I'm going to present on virtual mission schedulers for cloud computing. I'm from online participant from ECE 528 cloud computing class. First of all, introduction to uh, virtual mission scheduler for cloud computing. When it comes to virtual mission, operations like scheduling, consolidation, migration, and other supporting duties, cloud computing has fundamentally changed information technology. The network and architecture of the system have changed as a result of cloud computing. Virtual machines are pieces of software that use a computer environment to set up or run programs. The virtual machines resource allocations and the transfer of programs between virtual machines are crucial parameters. And the virtual machines are scheduled for a number of data centers in the cloud architecture, and some of which may be spread out geographically. Resource and infrastructure utilization are determined under the scheduling optimization process in a cloud computing environment. And when it comes to what is virtual mission scheduler, uh, a virtual machine scheduler is a software component of a virtualization platform that is responsible for allocating physical computing resources like such as we have CPU resources, memory resources, and input and output resources to multiple virtual machines running on the same physical host. Virtual machine scheduler typically use a variety of scheduling algorithms to determine which VM should be given access to the physical resources at any given point of time. And virtual machine schedulers frequently employ a variety of scheduling techniques like round robin scheduling property, uh, priority based scheduling, and fair share schedulings are some of the most used scheduling algorithms. By taking into account elements like CPU affinity, input and output bandwidth, and memory consumption patterns, these algorithms can be further optimized. In general, virtual machine schedulers are crucial for reaping the full rewards of virtualized computing environments by ensuring their dependable and efficient functioning. And now, why virtual machine scheduling in cloud computing? Scheduling VMs is crucial in cloud setting. It helps cloud infrastructure load balance and effectively distribute VM resources. To get the best file sharing, a cloud infrastructure based on virtual file sharing is used, and VM scheduling. Recently, cloud data centers manage traffic load balancing, energy use, etc. Hence, allocating resources in a cloud environment is a difficult process. Virtual machine scheduling methods created in a way that they can manage these resources allocation difficulties successfully. This technique is capable of allocating VM resources in both static and dynamic setting. This facilitates the inefficient use of resources, and the goal of a scheduling algorithm is to perform a variety of activities such as distributing resources and monitoring energy usage, executing costs, and execution time under the set parameters and limits. Uh, when it comes to types of virtual machine scheduling, we have five types. There are static scheduling, dynamic scheduling, heuristic scheduling, real-time scheduling, workflow scheduling. When it comes to static scheduling, we have PSO-based algorithm and min-min algorithm. The disadvantage of this algorithm is balancing the workload of virtual machines between independent tasks, and long tasks cannot be executed unbalanced load. And when it's come to dynamic scheduling, we have dynamic round robin, predictive virtual server scheduling. In the futures used in dynamic round robin is physical, while physical machine is in the retirement state on finishing a VM, but more VMs are waiting for it provisions the physical machine to retire and migrate VMs on another physical machine. When it comes to predictive virtual server scheduling, this scheduling method aims to predictive server scheduling for dynamic consumable resources, which works on priority based workload performances. And under scheduling is heuristic scheduling. In this also we have two types: generic algorithm with meta-heuristics, hyper-heuristic scheduling algorithm for cloud. For generic algorithm with meta-heuristics is scheduling tasks to the resources with adaptable time in a proper sequence so all the tasks can be executed. In the hyper-heuristic scheduling algorithm, diversity detection and improvement detection operators are used to dynamically determine better candidate solution. When it comes to real-time scheduling, we have two types. There are smart energy aware task scheduling and green scheduling algorithm for energy savings in cloud computing. For smart energy aware task scheduling, it provides optimal utilization of host to execute certain tasks in real time and minimize the energy. For green scheduling algorithm, the energy savings in cloud computing integrates neutral network predictor for optimizing host power consumption for cloud environment. And the last one, work scheduling. Here also we have two types: compromised top time cost scheduling algorithm, multi-objective workflow scheduling, based on instance cost constrained workflows but compromise execution time and cost. In multi-object workflow scheduling, it is based on task completion time and security requirements of cloud environments. And also for everything we have advantages and disadvantages. Here the advantages of virtual machine scheduler. There are 6 types of advantages. First one is resource optimization. In resource optimization, virtual machine schedulers enable efficient allocation of resources such as CPU, memory, and disk space among multiple virtual machines. This ensures that resources are used optimally and there is no resource underutilization or wastage. And the second advantage is workload management. Virtual machine schedulers allow cloud providers to manage the workload effectively by distributing the workload evenly among the virtual machines. This ensures that no single virtual machine is overloaded while others are underutilized. Another one is scalability. In scalability, virtual machine schedulers enable cloud providers to scale the resources up and down based on the client requirements. Fourth one is availability. Virtual machine schedulers ensure that the virtual machines are available to the clients whenever they need them. They do this by scheduling the virtual machine on different physical hosts, ensuring that if one host fails, the virtual machine can be quickly moved to another host. Another one is cost reduction. Virtual machine schedulers enable cloud providers to optimize their resource usage, resulting in lower cost. This is because they can avoid over provisioning resources which can be expensive and instead only use the resources that are needed. The last one is customization. Virtual machine schedulers allow cloud providers to customize their virtual machine configuration to meet their clients' specific requirements. This enables them to offer tailored solutions that meet their client needs, enhancing the overall user experiences. And disadvantages of virtual machine scheduler for cloud computing. We have some of the disadvantages also in virtual machine scheduling. There are complexity, overhead, scheduling inefficiencies, resources contention, complexity of migration, vendor lock-in. In complexity, virtual machine schedules can be complex to set up and configure, particularly in large-scale cloud environments. They require skilled personnel with expertise in virtualization, operating systems, and network administration. In overhead, the scheduling process itself can introduce overhead, which can impact overall system performance. This overhead can increase as the number of virtual machines and scheduling complexity increases. Scheduling inefficiencies. In some cases, virtual machine schedules may not allocate resources efficiently, resulting in underutilization or over-provisioning of resources. Resource contention. Virtual machine schedulers may not always handle resource contamination issues effectively. Complexity of migration. When migration of virtual machines from one physical host to another, there may be complex issues related to network configuration, storage, and security. Vendor locking. Some virtual machine schedulers may be proprietary, which can result in vendor locking. This can be difficult in switch to a different scheduler or cloud provider without significant effort and cost. Overall, while virtual machine schedulers offer many benefits for cloud computing, there are also potential drawbacks also. System model and problem formulation in virtual machine scheduler for cloud computing. Uh, uh, when it comes to system model, the system model for virtual machine scheduler in cloud computing typically consists of several physical hosts with each multiple virtual machines. Each virtual machine runs on a specific workload and requires a certain amount of resources such as CPU, memory, and disk space. This virtual machine scheduler is responsible for allocating and managing these resources across the different physical hosts. Problem formation. When it comes to problem formation, the problem formation for virtual scheduling in cloud computing typically involves finding the best allocation of resources for each virtual machine to optimize resource utilization, workload management, and overall system of performance. The main objective of this problem solution is to each virtual machine should be assigned to necessary resources to meet workload requirements while avoiding resource underutilization or wastage. Overall, the system model and problem formulation for virtual scheduler in cloud computing are complex and it requires careful consideration of various factors such as workload requirements, resource utilization, and system performance. Performance analysis in virtual machine scheduler for cloud computing. I have 5 types of performance analysis in virtual machine scheduler, that is resource utilization, workload management, system performance, efficiency, and user satisfaction. First one is resource utilization. One of the primary goal of virtual machine scheduler is to optimize resource utilization. Performance analysis typically involves measuring the amount of CPU, memory, and disk space used by each virtual machine and comparing it to the amount allocated by the scheduler. Metrics such as CPU utilization, metric utilization, and disk utilization can be used to evaluate the effectiveness of the scheduler in resource allocation. Second one is workload management. Virtual machine schedulers are also responsible for managing the workload effectively by distributing it evenly among the virtual machines. Performance analysis typically involves measuring the workload on each virtual machine and comparing it to the overall workload on the system. Metrics such as throughput, response time, and latency can be used to evaluate the effectiveness of the scheduler in workload management. System performance. Virtual machine schedulers can impact overall system performance, particularly when it comes to system responsiveness and availability. Performance analysis typically involves measuring system performance metrics such as system uptime, service availability, and mean time to failure. Fourth one is efficiency. Virtual machine schedulers can also impact the efficiency of cloud computing systems by reducing overhead and maximum resource utilization. Performance analysis typically involves measuring metrics such as system throughput, resource utilization, and response time. User satisfaction. Ultimately, the success of the virtual machine scheduler depends on user satisfaction. Performance analysis should include measures of user satisfaction such as customer feedback. And I want to conclude it. That is, when scheduling incoming tasks to the cloud, fewer actual servers should be used because these maximize resource consumption. The scheduler must effectively manage the demand on resources and execution times must be maintained to a minimum. We put the CloudSync toolkit to the test and examine how the virtual machine scheduler space shared, virtual machine scheduler time shared, and virtual machine scheduler time over subscription behave. The results show that compared to virtual machine scheduler space share and virtual machine scheduler time share, virtual machine scheduler time share effectively uses resources by distributing MIPS among virtual machines on a server, resulting in a decrease in the number of powered on servers in a data center and corresponding decreases in power consumption. Thank you.